For most of human history, the only light we knew came from the sky. By day the sun, by night an uncountable number of stars. We have been watching the sky for thousands of years, but now, through education in astronomy, you can see further and clearer than ever before, revealing our astonishing universe.
We're given an experiment by the universe, and a lot of times that experiment can't be done here on Earth. There's no way we could reach the energies or the scales, the masses that we can in space that we can on Earth. And so the astrophysics is really designed as taking what the universe gives us and trying to understand what that is.
You know, how does the universe work, and how do we go about understanding where stars come from, how energy is created, you know, how it moves through the universe to create what we see.
I think astronomy starts there. Astronomy starts with the big ideas and the big focus of looking beyond what we have in our everyday life.
It's a thrill of understanding how different things work, but also when we find something out there that we don't understand how it works, you know, making the discovery and learning something that we didn't understand before is really exciting.
And the bottom line is, that's our future. That's where we're going. We're going out there, one way or another. We've got, my local hero right now is Elon Musk of SpaceX. He's got plans for us to colonize Mars. I follow him greatly. I think he's got a great mind and a great plan to do this. So we're going forth, be it next year or 20 or 100 years from now, but space is our future. And so learning about it is just very exciting.
I'm a research astrophysicist. I work on the heliophysics division, and that just means that I study Sun-Earth interactions. So I do solar physics, which means that I study the sun and the atmosphere of the sun, which is called the solar corona. I also study the solar corona is not gravitationally bound to the sun. It flows off in something that we call the solar wind. I also study the solar wind.
So my primary research topic is studying the space environment of the Earth, and in particular we have the solar wind, which is flowing out from the sun all the time at 400 kilometers per second. And so a lot of what I've been working on lately has to do with how do you model these very different phenomena altogether. And so I've been constructing computer simulations of how the solar wind interacts with the Earth, its magnetic field, and how that energy gets transferred through the system to the different plasma populations, and what are the consequences of that interaction.
It's the best career. I'm still always learning new things, and it allows me to keep on top of things, but also share that enthusiasm with, you know, students and other people. It's one of the few sciences that is constantly evolving, constantly changing.
My primary area of focus is actually in the study of the atmospheres of extrasolar planets, primarily by using what's called spectroscopy, which is where we break the light up from the planet into its different colors, and we look for the fingerprint, the signature of various different atoms and molecules.
My field of interest is building instrumentation to look at black holes, but there's a lot of interest at the moment, particularly about exoplanets. So looking at sources in the sky and determining if those suns have planets going around them, and how many planets, and if they're Earth-like planets.
The research that I do deals more in planetary science. So what I look at is processes that occur on surfaces of satellites of different planets, and also on asteroids.
So the great ability to combine something that's so magical and exciting for students with fundamental understanding of different science, both, you know, for everything from the, you know, dynamics of physics and chemistry going on in stars and planets, all the way down to, you know, the history of science. You can teach everything within the realm of astronomy.
A career in astronomy, most likely you'd end up in a research university or a college. Over half the people who work in the field of astronomy work in a college or university. A large percent work for the government. The mathematical skills that you gain, the understanding of different physical principles is ideally suited for a number of different fields, such as engineering.
If you have an astronomy background, you have a physics background, and so you can teach many of the different sciences. Anything that involves computers or data analysis, that's what you learn how to do in astronomy.
Because he was very good at looking statistical analysis and looking for themes and trends in data, he was able to apply what he had learned as an astrophysicist to actually working for Fannie Mae, and they have him looking through huge quantities of data, looking for trends and things.
Work in industry, like in the defense industry, like developing new types of lasers or developing new types of information searching techniques. You learn how to analyze data, how to do statistical analysis, and those are things that have applicability far beyond.
It really is a very stimulating discipline to go into. It really answers some of the ultimate questions that we have. What is our place in the universe? Okay, are we alone? I mean, what bigger questions are there than that?
And it gives us a chance to think in ways that we haven't, that we're not used to thinking about, and expanding our mind.
Who doesn't want to understand? Everybody wants to understand what we're in and what's going on around us, and it's just cool. It's cool stuff.